All right, so now we're going to talk about multiplying monomials. So we're going to have another property of exponents coming up. Okay, so let's first just look at this. So this is 4 to the third times 4 to the fifth. So let's expand that out. So you have this on your paper, but I just kind of want to show you. So when we expand it, it's 4 times 4 times 4, because it's 3 of them. And it's that, times the 5 together. 4 times 4 times 4 times 4 times 4. Okay, and when we write that, how many 4s do you see? I see 8 4s altogether. That's why it's 4 to the 8th power. So I want you to pause right now, and I want you to practice expanding. Well, don't pause yet. I lied. Let's do one more together. So we have 7 to the third times 7 squared. So that looks like 7 times 7 times 7, because there's 3, times 7 times 7. So how many 7s do we have in total? We have 5 7s. Does that kind of make sense? Okay. So now I want you to pause and try the next 3 and see if you can come up with a property. See if you think you know what the rule is. So pause right now, expand these out, simplify it, and let me know if you have a pattern that you see. All right, so here's what we did when we expanded it. So for this negative 15 one, you should have gotten negative 15 to the 8, because we see 8 negative 15s that we're multiplying together. For 7 cubed times 7 to the 4th, we would get b to the 7, because I see 7 b's listed there. This last one's a little different, though, because I still see 3 5s and 3 2s. Sorry, and 2 3s. Okay, so those still stay how they are, because we can't combine them, because they don't have the same base. So that's super important. Okay, so what do you think that the rule is here? So do you have an idea of what you think the rule is? So looking at this, we're saying that it's a to the m plus n. So like an example, let's just use the one from up top. We had 4 to the third times 4 to the fifth. So that becomes 4 to the 3 plus 5, which is why it was 4 to the 8th power. So we use this rule and we just add up our exponents. So when we're multiplying straight across, we add up our exponents. Okay, so let's look at some of these examples then. Okay, so we're going to do a couple together, then I'm going to let you do some on your own. So we have the same base, so that's important. They're both 4. Okay, so since they're both 4, then it's 4 to the 11th plus the 6th power, which is then simply 4 to the 17th power. Okay. What about number 2? Number 2 is a little different. Now we have the coefficients in front. So this becomes 2 times 5 and a to the third plus the second. So now we do 2 times 5, which is 10, and then it's 10 a to the fifth. I'm going to do one more with you, one more, and then I'm going to let you try the next 3 on your own. Okay, so one more is now we have 2 variables together. So example 3, now I have 2 variables. So, and what do we notice about the c? What do you notice about the c? There's no exponent there. Well, there's none listed, but there is an implied 1. There's an implied 1 here. So it's really c to the first power. And we just don't write that because c to the first is the same thing as c. So this is really c1 plus 3 and d6 plus 1, because that's also an implied power of 1. And now c1 plus 3 is c to the 4th, and now we have d to the 7th. Okay, so now I want you to pause, and I want you to do examples 4, 5, and 6 for me. So I want you to pause and try examples 4, 5, and 6. Okay, So hopefully number 4 wasn't too bad. It should be 8x to the 4th, y to the 6th. So the only difference is that we only have one y, so that just kind of stays the same. Number 5, there was something a little tricky about that, is that now we have a negative sign and a 3. So that negative is really a -1. Okay, so we have a bunch of implied ones places. Same thing with 6, there's a -1. And now we have 3 things we're multiplying. So it did make it a little more complex, but I think once you see the work, it kind of works itself out. All right, so make sure you ask me any questions in class that we have. All right.